So for our second task, what we're going to do is show the number of coffee shops worldwide between 1987 and 1997. And the growth of the stores is roughly exponential. So if we look at the year and the number of stores, we can just see here that it's increasing. However, if we look at our graph, we can see that exponential curve. So if we found the average rate of change between 1990 and 1987, we would go to the Y value for 1990 and do 84 and subtract off the Y value for 1987, which is 17, and then divide that by 1990 minus 1987. So in this case, we're going to have 84 minus 17, which is 67. Over 1990 minus 1987 is 3. So I'm going to reduce that to a decimal. And we have 22.33. And what that means is we're averaging an increase of, that is going to be stores per year. So we're going to do the same thing for 93 and 87. So in 1993, we have 272 minus the 87 has 17. Over here, we'd go 1993 minus 1987 for the x2 minus x1. So on here, 272 minus 17 is 255. And then 1993 minus 1987 gives us 6. So now if I change that and go 255 divided by 6 to convert to a decimal, we see that that increase is 42.5 stores per year. And then here over the whole span, if we do 1,412 minus 17 divided by 1997 minus 1987, that's 1,395 divided by 10, which gives us 139.5. And again, that's stores per year. So some observations about the rate of change that we calculated. What did the average rates of change tell you? Well, the average rate of change is increasing over that span. So you can see here, relatively a small number of coffee shops, and then it just goes up and up and up and up. So now use the graph to support your answers. How well do the average rate of change describe the growth in the first 3 years? So in looking at that, our first rate of change was 22.3. So for the first 3 years, if we look here, this is 500, 400, 300, 200, 100. So we have up 100 and then over 3. The graph, if I estimated that, was 100 over 3, which is approximately 33.3. Remember, that's off because I'm just estimating. So if I looked at the average rate of change over the first 6 years, this seems to be at roughly To go from here to there, I'm going to estimate that to be 400, 300. I'm going to say like 390 over the first 6 years. So 6. So if I divide then, the average rate of change is about, if you see I overestimated, about 65. And then here for the entire 10-year span, that's going to be roughly 1,000, 1,100, 1,200, 1,300, about 1,400 divided by 10. And that's going to give us approximately 140. So you see our numbers are about the same on the graph, but we can get exact numbers from the table, which on the graph we get more estimates. So now let f be the function representing the number of stores since 1987. F of 20 is 15,010. And say what it tells us about the change in the number of stores. So over the next years, if I did f of 20, we have 15,011 stores, divided by, or minus f of 10, so minus 1,412, and then divided by 20 minus 10 is 10. So we're going to simplify that. So we have 1,599 divided by 10 gives us 1,359.9. So that rate of change over that from 10 to 20 years is even larger. So a larger exponential growth.